Most people naturally picture the Big Bang as a massive, fiery explosion happening inside a dark, completely empty room. But 13.8 billion years ago, there was no room. There was no outside to expand into, because space and time did not yet exist. Everything we see today was compressed into a point billions of times smaller than the nucleus of an atom. In this singularity, density and temperature were infinite, reaching a state where our known laws of physics simply stop working. At this stage, the universe was entirely composed of pure, blinding energy. To evolve into the current cosmos, that microscopic speck had to convert that energy into solid matter. This shift from energy to matter was only possible through one specific mechanism: a severe and continuous drop in temperature. This process began with cosmic inflation. Matter didn't explode into space. Instead, space itself violently stretched outward. In a fraction of a second, the universe grew from the size of a subatomic particle to something larger than a football. This rapid expansion forces a drop in temperature. As the volume of space increased, the intense heat of the singularity began to dissipate. As the temperature fell during that first second, the energy began to condense into physical particles. This conversion of energy into mass is described by Albert Einstein's equation, E equals mc squared. The first building blocks to emerge were quarks and gluons, which quickly bound together to form protons and neutrons. By stretching the fabric of space, the universe lowered its temperature enough to create its first physical ingredients. 3 minutes after the start, the universe was a dense, opaque nuclear reactor. It was still too hot for atoms to hold together. During this phase, called nucleosynthesis, immense pressure forced protons and neutrons to fuse into the first simple elements, hydrogen and helium. But the universe remains dark. A thick fog of unattached electrons moved so fast that they trapped particles of light, preventing them from traveling through space. This darkness lasted for 380,000 years, until the universe expanded and cooled further. Eventually, the temperature hit a point where electrons slowed down and bound to protons. This process, known as recombination, created the first stable atoms. With the electrons now occupied within atoms, the cosmic fog cleared. Light was finally able to move freely across the vacuum for the first time. This map shows that first light, which has stretched over billions of years and is still detectable today as the cosmic microwave background radiation. Cooling transformed the universe from a blinding soup of trapped energy into a transparent cosmos. The universe was now filled with vast, drifting clouds of hydrogen and helium gas. Over the next few billion years, gravity became the universe's primary force, pulling these massive gas clouds together. As gravity compressed these clouds, the internal pressure caused temperatures to rise again, eventually triggering the nuclear fusion that birthed the first stars. Those stars bound together to form the first galaxies, and the expansion that began 13.8 billion years ago continues today. Every atom in our bodies is the result of that initial burst of energy cooling and condensing over billions of years. We are the physical remnants of the beginning of time.